So hi guys, welcome back. So right now we're going to continue from where we left during our class lecture. Okay, so time scaled activity diagram. So by definition, a time scaled activity diagram presents a graphic and illustrations of project as a network diagram consisting of number nodes. It is either in circles or rectangles, representing events or milestones in the project linked by labeled arrows. It is directional, by the way. Now, representing tasks in the project. The direction of the arrows on the lines indicates the sequence of tasks. The arrows' varying length represent the timing and the time span for each task. One of the benefits of having a time scale diagram is that you are having a great visual of how the project is going, or how fast or how slow the project is going. It is a good indication and way to show you if your project is delayed or if your project is on time. Okay, so let's proceed. Time scale event have two bases. So you have the early start, wherein you will be having free floats, wherein you can adjust your time. And the late start. For late start, we no longer have any free floats. That's why the project can no longer be delayed. Once it is delayed, therefore the whole project is being affected. And one of the benefit also of a time scaled network is that you can see the dependency between between activities, the dependency between activities, and the flow of your activity. So for the procedure, number one, identify the earliest start and the latest finish of each activity. Number two, locate the critical path. Number three, draw the representative nodes corresponding to each other, the early or the late starts. And number four, redraw the network diagram by connecting the previously drawn nodes with the use of arrows. The arrows' length vary depending on the duration and float of each activity. A solid arrow represents the activity duration, and a broken arrow represents the activity's free float. So if it is a straight line, a solid straight line, therefore it has a duration. If it is a broken arrow, therefore it is simply a free float. Okay? Let's try this activity. You have here from activity 1 to activity 11. So redrawing that activity to our paper, of course it should look like the same, no? The first thing that we need to do is to solve for the earliest start. Okay? We all know that the earliest event will always be assumed to be 0 for the early start. Okay? So for the early finish, it would be the early start plus the duration. So 0 plus 10 is 10. Okay? 10 plus 2 is 12. 10 plus 3 is 13. Okay, let's write the solution. 10 plus 2, 12. 10 plus 3, that is 13. 10 plus 6, that is 16. Okay, let's continue with 3 to 6. 12 plus 7, that is 19. 19 plus 3, 19 plus 3, that is 22. 22 plus 0, that is still 22. Activity J, we have 19 plus 4, that is 23. Okay, we also have here 6, 7 to 10, but we need to solve first L, the early start of L, and that would be 16 plus 3, and that is 19. Okay, am I right? So 16 plus 3, that is 19, yes. So whichever is the biggest will be adopted as the value of the early start based from our rule. So that is 19. So 19 plus 1, that is 20. 20 plus 6, that is 26. Okay? Whichever is the greatest number of these three, 22, 23, 26 will be adopted, and that is 26. Okay? So 26 plus 3, that is 29. Okay, let's continue. 4 to 8. 16 plus 5, that is 21. 20 plus 0, that is 20. Therefore, we're going to adopt 21, being the highest. 21 plus 7, that is 28. Therefore, the duration of our project is 28 days. Okay? Now, what we need to do is to solve for the late finish. And in doing so, we need to solve it backwards. Okay? Being 99 being the duration, we're going to use 29. So 29 minus 3, that is 26. So 26 minus 0, that is also 26. Yeah? So 26, yes. 26 minus 3, that is 23. So we have here 23. But we're not yet done because we still have activity 6 to 10. We need to check whichever is the lowest. This time, the lowest value will be adopted for the late finish. And that is 26 minus 4. 26 minus 4, that is 22. Therefore, we're going to adopt 22 being the lowest value. Okay? Now, 22 minus 7, that is 15. 15 minus 2, that is 13. We cannot yet proceed because we still have two nodes, two arrows, that is 2 to 5 and 2 to 6. Okay? So let's start with, let's go back with activity 7 to 10. 26 minus, so 26 minus 6, that is 20. Are we sure that it is 20? Let's check first 7 to 8. So we have 29. So 29 minus 7, that is 22. This is 22. So 22 minus 0, 22 minus 0, that is 22. Therefore, the smallest is 20. We're going to use 20. Okay? Next, 20 minus 1, that is 19. 19 minus 3, that is 16. We still have another one left, that is 2 to 5, 2 to 4 rather. So we have here 22, 22 minus 5, that is 17. 20, 19. 19 minus 3, that is 16. So we're going to use 16. 16 minus 6, that is 10. Between these three numbers, 10, 13, and 16, the lowest value is 10. Therefore, we're going to use 10. So 10 minus 10, that is 0. Okay? We are now ready to determine our critical path. Okay? So first, let us identify what our paths are. We have AC, ACLMO, ADE, HOKO, ADEJO, ABFLMO, ABFLIN, ABGN. So that's the paths available. I have written here the paths. So you have ACLMO. A has a 10 days duration, plus C is 3, plus L is 1, plus M has 6 days, plus O has 3 days. Okay? And that is 10 plus 3 plus 1 plus 6 plus 3. That is 23 days. Okay, next we have A as 10 plus D, which is 2, plus E, which is 7, plus H, which is 3, plus K, which is 0, plus O, which is 3. And that is 25 days. 25 days. Next, we have this path. So that is A 10. So that is 10 days plus D, which is 2 days, plus E, which is 7, plus J, which is 4 days, plus O, which is 3 days, and that is 26 days. Next, ABFLMO. So you have A, 10 days, plus B, which is 6 days, plus F. F is 3 days, plus L, which is 1, plus M, 6, plus O, 3. And that is 29 days. Next, we have this path, ABFLIN. A is 10 days, plus B, which is 6 days, plus F, 3 days, plus L, which is 1, plus LI, 0, plus N, which is 7. And that is equivalent to 27 days. A, going back to A, we have 10. So you have 10 plus B, which is 6, plus 5 plus 7. And that is equivalent to 28 days. Therefore, our critical path is this. So you have ABFLMO. The next thing that we're going to do is to plot it. And create our time-scaled network. Isn't it a while ago we said that we will be having two bases. It is the early start and the late start. So the first thing we need to do is to do the early start. So the first thing we need to do is to plot our critical path, and that is ABFLMO. Okay? Because it is the critical activities. So we have A as 10 days. So we have A as 10 days. So I am going, every column here is representing a duration. So for our case, I used 1 centimeter as an offset for each column. And each column is representing 1 day each. Okay? So we have here activity A as 10 days. So what I'm going to do is simply draw a straight line because it has a duration of 10 days. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. Activity A, 10 days. Next critical activity is B. And activity B is 6 days. So simply connect, but don't forget we have our node here. We have node number 2. So here we have node number 1. Node number 1, node number 2. Okay? Activity 2 to 4 is activity B. Therefore, the next node is 4. And B has 6 days. So we have 1, 2, 3, 4, 5, 6. So we have here node number 4. And this is activity B, which is 6 days. Following activity B is activity F. Activity F has a duration of 3 days. And activity B to F is 4 to 5. Therefore, the next node is 5. So we have 1, 2, 3. So this is node number 5. And this is activity F, 3 days. The following activity of F for F is activity L. So we have here activity L. Activity L is 1 day. And activity L is 5 to 7. So the next node is 7. So this is L, 1 day, node 7. Okay? Next, the following activity from L is M. M is 6 days. So let's just simply draw 6 straight line for 6 days. So we have 1, 2, 3, 4, 5, 6. And the node is 10, 7 to 10. This is node 10. Okay? And this is activity M of 6 days. And the last is activity O. Activity O is 3 days. Therefore, we're going to draw 3 straight lines. 1, 2, 3. And this is node 11. So we're already done with our critical path. We can now draw other paths. Okay? So to make it easier, let's just base it on the diagram. Okay? So we have here activity C is dependent on activity A, and it is just 3 days. So activity is dependent on activity A. Activity A will be finished on the 10th day. Therefore, we can start our activity C here. And its duration is 3 days. This is activity C. Connect it with a straight line. So C is 3 days. 3 days is connected to activity or node number 5. So it is connected to node number 5, but it is just 3 days. Therefore, the remaining days would be a free float. So we're going to draw it in a hidden line or broken line there. Next, we have activity D. Activity D is also dependent on activity A. Activity D dependent on activity A. So activity D is 2 days. So we have here activity A after 10 days. So we have here activity D. It is just for 2 days. Again, it is a solid straight line. The activity next to D is activity E, and activity E is 7 days. So we're just simply going to connect it. So we have 1, 2, 3, 4, 5, 6, 7. So this is activity E, and it is 7 days. Next, we have activity J. Activity J is 4 days. So let's just continue. We have 1, 2, 3, 4. This is activity J, and it is 4 days. And lastly, we have activity O. Activity O, and it is for 3 days. Okay? So it is activity O, but activity J is just 4 days. Therefore, the remaining days would be a free float. So we have here a free float of 3 days. Okay. Going back, activity H also is dependent on activity E. Okay. So we have here activity E. So activity E, J rather, is dependent on activity H is also dependent on activity E, and it is 3 days. So we have 1, 2, 3. And this is activity H. And it is 3 days. Therefore, the remaining The remaining days would be, no. It has a dummy account, and that is K. Okay? Therefore, we're going to add another node here. And that node is node number 9. So, this is node number 9. We forgot the nodes. Activity D to D is node 2 to 3. So, we have to include here node number 3. So, that's it. Then activity E is node 3 to 6. Node number 3 is 3 to 6. So we have to place node here. Node 6. Then yeah, activity H is 6 to 9. Okay, again, this is a dummy activity which is K. And it is connected to node 10. So you have here K 0. Okay, we're already done with the upper part. Let's go with the lower part. So we are left, we already plotted BF, yeah. So this is BF. So what's left is GN. So these two activities. So G is dependent on activity B. So activity B would be finished on the 16th day. So G is dependent on activity B. So let's draw a straight line here. And activity G is 5 days. So let's draw 5 straight lines. 1, 2, 3, 4, 5. And activity G is 4 to 8. Therefore, the node here is 8. G, 8. Okay. Next, we have activity N. Activity N is dependent on is dependent on L and G. Okay? So therefore, we're just going to connect it with a hidden line because this is dummy. That is K. Is it? No, it's not K. It's I. This is I. Okay? Then, activity N is 7 days. So let's just draw 7 straight lines. 1, 2, 3, 4, 5, 6, 7. This is N. And that is 3 days. So we have one remaining day. Therefore, it is a free float. So connect it with a hidden line or broken line. So this is the diagram for our early start. This is our time scaled network for early start.